video is about definite integrals. So write the title, read the learning objective, and if you need to pause the video to give yourself time to do that, then do it now. So far, we've looked at indefinite integrals. So for example, if you're asked to integrate 3x squared with respect to x, hopefully you're very clear by now that that is x cubed plus c. This is called an indefinite integral, something that we've done a lot of. Today's video, looks at definite integrals. This is what a definite integral looks like. What's the only difference between a definite and an indefinite integral that you can see in front of you? Hopefully you've noticed, definite integral has these two numbers at the top and the bottom. We call these numbers limits. Now, a definite integral, you calculate by calculating the integral. So as always, you integrate the expression here. But then what we do is we substitute the limits into the integral. So instead of x cubed, I write 2 cubed, that's the first limit. And instead of x cubed, I write 1 cubed, that's the second limit. And I find the difference between them. There's no plus c for definite integrals. It is just a matter of substituting the limits in place of your variable and then calculating the difference between them. 2 cubed is obviously 8, 1 cubed is 1. And so overall, the definite integral of 3x squared with the limits 2 and 1 equals 7. So whereas with indefinite integrals, we tend to get a function, for definite integrals, we get a value, a number. So pause the video and make any notes that you need to, and then we'll do a couple more examples. So if you're asked to evaluate, key is in the word value, evaluate, so find the value of the integral lying between the limits of x to the third minus 1 all squared with respect to x. I want you to pause the video and have a go at doing that on your own first. Alright, so first of all, we've got to deal with this power, because we can't integrate if we've got a bracket times a bracket. So remember, when you're squaring something, you're talking about the square of the first thing. So x to the power of a third times x to the power of a third is just x to the power of 2/3. X to the power of a third times -1 is negative x to the power of a third, but then we double it, so negative 2x to the third, and then -1 times -1 is positive 1. Now, this is in a nice form so that we can integrate it. Now at this stage, hopefully you're starting to get good at this and you're starting to be able to do this in your head, integrate in your head. But if you're not, you're still going to have to write out the working over here. So unlike before, like the original dy by dx is now on top and the answer, the integral, is going to be on the bottom. But just so that we set it out in the way that we did before, if you want, you can write y equals and dy by dx equals, and remember, if you're aiming for this, that means y would have had to be 5/3. Obviously, when you differentiate that, you get 5/3 in front of it, which is not what you want. We wanted 1, so we have to times it by the reciprocal, so we times it by 3/5. So our first term in our square brackets is going to be 3 over 5 x to the 5 over 3. So this is the sort of working out that you need to be doing at the side if you're finding it hard still. I'll zoom out a little bit and I'll do the second one like that as well. So this time we're looking at this term here, trying to figure out what y is. I know that the derivative is negative 2x to the power of a third, so it must be x to the power of 4 over 3, which differentiates to 4/3 x to the power of 1 over 3. That's what I wanted in terms of the power, but I wanted a negative 2 as the coefficient. So what do I times 4 over 3 by to make negative 2? Well, if I times it by negative 3 over 2, then they're going to cancel out. 4 divided by 2 is 2, and I'll get negative 2 overall, which is what I'm aiming for. So that needs to be negative 3 over 2. So there I'm going to write negative 3 over 2 x to the 4 over 3. And hopefully, like, you can just do this in your head now. That's plus x. But then remember, the difference between this lesson, this video, and all the other videos we've done is now we have limits. So the way we integrate is the same, but instead we've got limits. Now, we're going to substitute our limits into our integral. This thing is the integral, because we've integrated the original expression. 3/5 times 1 to the power of 5 over 3 is just 3/5. Negative 3 over 2 times 1 to the power of 4 over 3 is just negative 3 over 2. And then plus 1. Take away, subbing 0 into each of these, it's just 0 minus 0 plus 0. If you calculate all that, you end up with what? Type into your calculator. Let's do it quickly. Where's the calculator? Whatever it is. Yeah, 1 over 10. And that is the value of the definite integral that we're given in the question. So make sure you've written any purple pen notes that you need to. If you realise that at this stage you need to do some more practice on integrating because you're not happy about this stage over here, then you may need to go back and redo some of the other exercises that we did before. So exercise 13A, B, C. The next example we're going to do is example number 8 from the textbook. So read the example, read the question, and I want you to pause the video and have a go doing this on your own before I go through it. So do that now. So we're told that, given that P is a constant, so immediately I'm thinking it's not going to be affected by the integration or differentiation processes, and we're given this information about a definite integral here, we're told that that equals 4p squared, so there are two possible values for p and find these values. So what we need to do is we need to find the value of the definite integral. So we need to find this out. When I've got a value for this, then I'm going to make it equal to 4p squared, and I'm going to try and solve to find the values for p. So let's start off by, we can integrate this immediately. So if this is x to the power of 1, I'm going to try and do this in my head, but I'll model the thinking. That needs to be x squared. But remember, when I differentiate x squared, I get 2x. But what I want is 2px, which means I'm going to have to multiply this by p. Let's just double check. Px squared differentiated, that gives 2px, so I know that's correct. And obviously 7x differentiates to 7, so that's done. But remember, this is a definite integral, so we've got to include the limits. And the next thing we do is we substitute the limits in and then find the difference between them after we've substituted. So the first bit is going to be p bracket 5 squared plus 7 bracket 5 minus p bracket 1 squared plus 7 bracket 1, which is obviously just 7. So this is going to be 25p plus 35 minus p, and then minus the positive 7 is going to be negative 7. So if I simplify all that, I get 24p plus 28. So that's the value of my definite integral. Now I'm told that is equal to this. So let's set up an equation. 24p plus 28 equals 4p squared. Now we have to show there are two possible values for p and find these values. Now, to show there are two possible values, you'll notice I have a quadratic here. I could actually just use the discriminant once I've rearranged it into the form ax squared plus bx plus c to show there's two solutions. As long as the discriminant is greater than 0, then we know that it's got two solutions. But given that I need to find the values, I might as well just go about finding the values, and that shows that there are two values of p that are possible. So let's move all on one side. I'm going to take away both the 24p and the 28 both sides, giving me 4p squared minus 24p minus 28. I'm going to divide everything by 4, which gives me p squared minus 6p minus 7. I'm then going to factorize to solve to find p. So p minus 7 plus 1. P therefore equals 7 and p equals negative 1. So those are the two solutions for p that I found, which answers the question that there are two possible values of p, and those are the values. So now you're ready to do exercise 13D. Check very carefully on Show My Homework which questions you need to do. See you later, bye.